Hi everyone, welcome back to the channel. Today we have another complex problem which is definitely going to give you a lot of concepts when it comes to preparing for JEE Olympiad or even GaoKao China. This problem was suggested by one of our subscribers and viewers, Mr. Aryan Shah, and I suppose he is preparing for IIT JEE. So let me state the problem first. If you see, there is a rod here, this rod, and this is a cylindrical rod which is standing initially almost vertically on a frictionless floor, and in fact the wall is also frictionless, and then slight nudge is given to the rod in this direction, horizontal direction, then it starts sliding down. And then the question is, what is the angle theta when this rod loses the contact with this wall? Okay, so that we need to compute. And there is another part that we need to also compute the velocity of center of mass when it loses the contact with the wall. Okay, so this is pretty good problem and there are some surprising facts here. And if you stay longer, I'll be covering some of the concepts as well. So I would request everyone to just pause the video and give it a try and then come back and see the solution. Okay, so let's first draw a free body diagram, simple free body diagram, and then we'll proceed. Okay, so let's say this is the wall and this is the floor, and at any moment t, the rod is like this. Okay, now this angle is theta, and there is a normal force here. Let's call it N1, and then there is another normal force here. Let's call it N2. Okay, the weight is acting downwards. Now, if we try to write the equations, usual the F equal to ma equation using Newton's law, and then torque equation, this problem is going to get very, very complicated. Okay. Instead, let's first observe what's happening. So if you analyze this, initially when this is standing, let's say here, and when finally it is on the ground like this somewhere, then what do you think, how much distance is traveled by the center of mass, if this is the center of mass? So center of mass, the vertical height that it covers is nothing but equal to L by 2, because that's what it's doing. Initially when it's standing, it's somewhere L by 2 and finally it's 0. So the center of mass movement in y direction is L by 2. If you take this x and let's take this as y, we can put negative sign here, but you understand we are talking about the absolute distance traveled by the center of mass. The normal force, both the normal force, this one is trying to rotate like this and this one is trying to rotate like this, right? And then due to gravity, it is falling. So the center of mass, if you trace the path of the center of mass, it starts from L by 2 here, and then it goes like this. It is following until it loses the contact. It is traveling in a circle of radius L by 2. Okay, but let's say that without this also, let's try to solve the problem using energy conservation. So there is no friction force, so the work done by friction is 0. That means we can just simply conserve the energy. Okay, so if this is making an angle theta, let's draw this again, this triangle. Okay, and this is L by 2, so this is theta, and hence this is L by 2, so this distance is nothing but L by 2 cos theta, right? And then initially it started from L by 2, center of mass. So center of mass was initially at height L by 2, and at any moment time t when the angle is theta, the center of mass is at height L by 2 cos theta, right? So if you take this point as P, then the coordinate is x and y, then x is L by 2 sine theta and y is L by 2 cos theta, right? Therefore, the drop in height is mg L by 2 1 minus cos theta. Okay, it acquires, let's say, a velocity v square, and then plus half I omega square. Okay, so I will deal with I as it is, although in this case we know that I is ml square by 3, and we'll put this value to compute the VCM. But let's deal with I itself, because there is a surprising fact that you will get to know in the end. Okay, so we know that there is a omega is nothing but v L by 2, right? So we can just simply write 1 by 2 I v square by L square into 4. This has 1 by 2, so 1 plus 4I by M L square, and therefore v square is equal to G L 1 minus cos theta divided by 1 plus 4I by ml square. So this is the equation for v square. In fact, we can write v as 1 minus cos theta and root of this. And therefore, we can simply say v is equal to k 1 minus cos theta, where k is some constant, which is gl by k. So let's deal with this one. Okay, so this v, if you see now, let's analyze this once again. This is theta, this is continuously increasing. So the velocity of this point P is nothing but L by 2 theta dot, and the acceleration is L by 2 theta double dot, right? This is how it is going. Now, if you see this angle, this is theta, this is 90 minus theta, and this is also theta. Okay, so what is Vx, velocity in this direction, x direction? Remember, we have taken x here. So this is nothing but V cos theta, which is k 1 minus cos theta, cos theta. Okay, this is Vx. So write the equation Fx equal to max. Okay, x is this direction. Now in x direction, there is only one force n1. So n1 is equal to max. Ax is the acceleration in x direction, right? There are two ways to solve this problem now. Okay, so the first way is that at break off, or when the rod leaves the wall, n1 will be 0, right? Therefore, max will be 0 according to this equation. Okay, now what is ax? Ax is nothing but dvx by dt. Okay, and what is vx? Vx is k 1 minus cos theta, cos theta. Okay, differentiate this function, can take k outside, and we get 1 by 2 1 minus cos theta sin theta cos theta minus 1 minus cos theta and sin theta. Okay, and then we also get theta dot, because d theta by dt will come. Therefore, k sin theta cos theta by 2 1 minus cos theta. If we take this as common, then this will become 2 1 minus cos theta sin theta theta dot. Okay, and therefore we can take the sin theta outside, 3 cos theta minus 2 divided by 2 1 minus cos theta and theta dot. We know that ax is 0, so we need to just put this as 0. We also know that theta dot is not equal to 0. Therefore, k sin theta 3 cos theta minus 2 will be 0. And therefore, we get cos theta as 2 by 3. Okay, so the answer is actually B here if you go and check the options. Okay, can you see one fact here? So this cos theta is independent of I, and that means independent of the shape. Okay, for any shape, this cos theta is going to be 2 by 3. Okay, now the velocity is nothing but k 1 minus cos theta. Therefore, k, this is going to be 1 by root 3 into 2 by 3, and k is nothing but GL 1 plus 4, and I is ml square by 3 into ml square, cancel out, and therefore this will become 3 GL by 7. Okay, for rod. Okay, now let's also see the how to solve this in second way. When the rod is breaking off, at the time of breaking off, Vx will be maximum, right? That means dVx by d theta should be 0. And we know that we just computed the dVx by d theta here. This is d theta by dt. Therefore, we again get the same cos theta. 3 cos theta minus 2 should be 0. And therefore, cos theta is 2 by 3. Both are fine. We can use normal equal to 0, or we can say that when the velocity is maximum in the x direction, then only it will leave the wall. Now, another point to note here is that the Vx or Ax will remain constant, okay, and Ax will become 0 once rod breaks off. Okay, and Vx will just remain constant. I hope you note these two things. I'm sure you would have learned few things here and you would have liked this video. So thank you very much. Thanks for watching. Subscribe and gain access to concepts and tips for doing better in IIT JEE or other examinations. Keep up the great work.